When you drop a glass mug, it shatters into a bunch of pieces. But have you ever seen these pieces jump back together into a perfect mug again? That's weird, right? Because technically energy is still conserved, so why doesn't it happen? The first law of thermodynamics says energy is conserved. That is true, but it doesn't say anything about direction. It doesn't explain why some things happen and others never do, even if they conserve energy. That's where the second law comes in. We're not going to be solving problems in this video, it's mostly conceptual. But here's some real world examples. For example, you have a hot cup of coffee in a cold room, and the room around it doesn't get spontaneously hotter, while the mug gets hotter too. That would conserve energy, but we never see it. When a rock hits the ground, it warms it up. But the warmth of the ground doesn't launch the rock back up. When you mix salt and pepper, they blend, but you never see them unmix. And same example from the start, when a mug breaks, it doesn't unbreak. What am I trying to get at here? These are all one-way processes. You cannot reverse it. Energy is conserved, but something else is happening. The second law says heat can flow spontaneously from hot to cold, but it cannot flow spontaneously from cold to hot. Let's break this down. Heat can flow from hot to cold. This happens all the time. Things cooling down. Heat will not flow from cold unless you force it to, like in a fridge, which uses a motor to pump heat backwards. What this law does is it gives us a direction. It tells us what can happen and what won't, even if the energy technically balances. The second law is not about numbers, it's about reality. Like why time moves forward but not backwards. Why things decay, and it's why engines can waste energy. It's not just about heat, it's about what's actually possible in real life. It's like why you age, why entropy exists.